Well, good morning. It's starting to get cold here. We're getting below freezing of a morning now, and I'm off for the rest of the year, so I'm hoping to get in some videos. Anyway, today I have for you a similar meter to the one that I've shown before. That was sent in by a viewer of the channel. So I'd like to thank them for sending this in. Really appreciate it. The meter here is a Hewlett-Packard 400EL AC voltmeter. The previous one, and I'll link it in the description, that I showed was a 400F that I had. The 400EL is the model beforehand, and this particular meter is the EL version, not the E. Now, the difference between the two meters is basically they're all just an AC voltmeter. That's all they are. The difference comes in how the display or the scale is actually printed. In a E meter, or 400E or the 400F, they're primarily designed for volt measurements. So the top scale will be a linear volt scale. And then what they'll have on the bottom is a dB scale that is calibrated as a logarithmic scale, and it's designed for showing that dB value, but primarily that meter is for the AC measurement. Now, the EL and the FL, I think it's the FL, they're primarily dB meters. Even though they're still measuring AC voltage, they're being calibrated, and the front surface of the meter is designed to show a linear dB scale at the top, and then we have our volt scale at the bottom. And so over the top here you can see, -10 to 0, +2, and our volt scale is on the bottom. And so that's what this meter is here. This is the EL, it's the dB version. And if we look down here at the range, you can see that we have the dB markings on either side, and then on the inside we have the volt ranges. Now this can go up to, I believe it can accept up to 500 volts AC, and it has a 300 volt AC range on it, which means that it can get quite a high voltage coming out in terms of dBm. Now, these units, or this unit in particular, I have to go back and look at the 400F, is calibrated for a 600 ohm load. So when you're reading 0 dBm here on the dB scale, which is here, what you're going to be getting with this being set at 1 dB or 0 dB setting here, this will give you 1 milliwatt as it appears in a 600 ohm load. So if you're wondering why 600 ohm, when probably most of the stuff you've seen, if you've been using RF, is 50 ohm. If you've been into security or closed circuit TV or cable, it'd be 75 ohm. It really was quite an interesting point in time in history. It came out of the Second World War, and basically what they were looking at with the 50, the 70, and then the 600. With 50, they basically were saying that there's for a particular cable, type, basically you have an interconnect conductor, dielectric, and outer sheath, and so on. To get the most power being transferred down the cable, you're going to end up with something, around the 30 ohm impedance for the cable. And if you want to get the least loss in the cable, you're going to be able to turn around somewhere around 77 ohms or so for the least loss. And so they basically took the geometric mean of that and said 50. It also turned out that just using standard wire and tubes was roughly 50 ohm impedance anyway. But that doesn't answer the 600. The 600 came originally from telephony, and was set up with the twisted pair wires and the relays that were in telephone exchange to roughly be a 600 ohm line. And that's 600 ohms roughly at the frequencies that they cared about in terms of the middle of the band of spoken frequencies. As you change that frequency, you're going to change the impedance. And so this is really referred to as the nominal impedance for the cable at 600 ohms. So with that case here, these things were targeted primarily at a 600 ohm rating. And in fact, if you read the manual for these things, they actually have a nice little graph that shows you what you need to do in terms of the impedance that you're trying to get and how many dB offset you'll need to do to actually convert the value here to the right value that you're reading. Anyway, that's why they're 600 here. Now, on this meter, basically all you have is an input. Because this is designed around the dB, it has a BNC connector coming in. We have the control here and line and so on. On the back of the meter, it's actually a little bit more interesting. What you can see here is the ability to run this off a battery, and 35 to 55 volt batteries is what we used. Some of the older meters actually would include a NiCad, or some of the other meters would include a NiCad battery pack to allow you to run it in there. I don't think this one's provided that as an option. I think it was just an external battery. Anyway, over on the right-hand side here, we have, let's take a look. We have a DC output. Let me see if I can get you some better light in there so we can see that. This is a DC output and then an AC output. And so HP talked about these meters being useful in two additional cases other than just reading the voltage as an AC voltmeter. One, you can actually use it as an early concept of a an AC to DC converter. And so what you can take out of here is you can feed in your AC signal, and you'll get a DC output that is proportional to the signal you're getting. That's basically the reading of the meter with the range and so on will come out on these terminals. This is what you would see on other instruments as a recorder terminal quite often, where what you would have is you have a 0 to 1 volt that is basically the offset of where the meter movement is at any given time. The other thing they allowed you to do was a fairly wideband AC amplifier. And so this AC output here will be an amplified version of the input, and that would enable you to go and take signals, amplify them, and then use them in other parts of your measurements. Now, the bandwidth of this, the 400E and EL, is actually better than the bandwidth of the 400F that I showed earlier. This one goes from 10 hertz to 10 megahertz, which is a much wider bandwidth, and that applies to that wideband AC amplifier as well. The 400F, I think, only did 10 hertz to 2 megahertz or something like that. Anyway, that's a quick overview. Let's take a quick look at the screen here, because I want to show you something that tends to happen with these old meters. Okay, so if we look here, and let me see if I can zoom in a little bit more. Hang on a sec, drink of the day, decaf coffee again, trying to get some of these videos done in the morning. Let's zoom in a bit. Now, what I wanted to show you is this is quite a common problem with the these older period meters. If you look in there, what you can see is that there's what looks like a bunch of flakes. Now, how they did this display is basically to put a decal down over the meter surface. And that worked fine. The trouble is that over time, that decal starts to lift off fragments, and those little fragments can catch the meter movement and cause it to stop working. So if you pick up an older one of these meters, you should check to see, or if you're looking to buy one on eBay, check to see whether you get a good view of the meter surface and see if it's peeling up. On this one here, there is a little piece of the decal over here near the 7. And what you'll see is the meter movement will catch on it every now and then. At some point, that's going to lift up and block the meter movement completely. So I'll have to go in and clear that little piece of the meter out, little piece of the decal out to let the meter move clearly. Okay, with that, let's zoom back out and let's take this guy apart. Oh. Screws running away. This is a fairly standard for this era of device. This form factor was fairly standard for a bunch of HP gear, like the 435s and so on. Okay, well, there we go. We can see inside the unit. Let me zoom in again so we can get a better look in. And let's take a look at what we have going through here. Now, this is a little hard for me to see because I have my light in the front here. All right, so what do we have? At the start here, this is our power supply section. You can see the battery voltage, the battery terminals coming in here. If we were to look under the board there, you'd see the input filtering for the power line coming in. The power line's actually quite interesting. It's not in this particular meter, it's not an IEC plug. It's actually one of these. And these are a PH163. These were very common in older HP gear. They're very hard to find cables now with that connector on them. You can replace the port. It isn't that hard. You'd nibble out the metal, put a proper IEC socket in there. Anyway, I have an original cable, so I haven't bothered to do that to any of my units here. So this is the power supply section. Then the next section we'll have here is, this is the impedance matching section, where we'll go and, as part of the process, as the signal comes in, let me see if there's, you can't quite see it. If you see that little box there, that's the input section in there, and there's there's a relay in there, and then there's some attenuation and so on that will attenuate the signal coming in as the range switch is switched down. The relay throws in and then starts to do that. And then it goes into, I think, it goes into an amplifier, then comes into some additional attenuation, and then that goes into the impedance matching section there. And then this is the meter bridge section here, where you can see where it's connected to the drives that meter there. And it's a fairly simple design, but again, you can see the way the board layout looks. It's very, very standard for that era. And if we look over down the back here, you can see that there is, I don't know if that's, I think, may actually have a blown out item there. I don't know if it's blown out, but it's definitely, you can see that there's a lot of dark, burning stuff in there. So either that's running very hot, or somebody has blown the DC output part of that. Anyway, we'll give that a try and we'll see what goes there. Let's take this side off, see if there's anything interesting looking in this way. Now, the great thing with these, the standardized cases, is that if you do get one and you do need to replace physical mechanicals, you can do that. Let me zoom back out. You can do that by picking up other meters that are similarly styled, because they'll basically be the same, mechanicals in terms of the frame and so on. There isn't a lot very interesting that you can see in here. This is the that input section. You've got down in there. Let's see if we can maybe go on the other side. You can see the range switch and the additional attenuation that's in there. Somebody's clearly had this apart because all the screws are different sizes. Okay. No, it's got a cover on it as well. If you look in there, you can see the shaft that comes from the range switch, and that has the all the attenuator parts for the range switch in there. And that little piece at the front there, that was where the relay is that is going to turn in that extra input attenuation on the lower ranges, on some of the ranges there. Okay, well, let's put this back together and take a look at it actually in operation. So to show you the meter in operation, I thought I'd bust out the 651B oscillator, which is actually the oscillator that's spec'd in the manual to do the adjustments and calibration for the unit. So let's turn these guys on. And the first thing that I'm going to go do is let's just set it for, say, 1 volt. And we'll set this guy for 1 volt there as well. And let's drop this in. Now, we're going to be measuring 600 ohms there. So to make sure that I'm driving it correctly, we'll need to have a 600 ohm load. So let's drop that 600 ohm load in. And now what you can see is I have this set to 1. So let's take this up here to 1 volt. And you'll see it's driving a little bit over. So if we bring that, let's just bring that down here. What you can see is, if we look, where's my little pointy stick? You can see that we're on, make sure that I'm actually on the right range. We're on 1 volt here. So on this is a 50, this is volts RMS here, and you can see that I'm reading here on volts RMS 1 volt there. So if we bring this down to, say, 0.5 volt, let's see if I can show you that. Oh no, it looks like maybe that there. You see it just there? As I move the meter past it, it's just catching on a bit of that decal. Now, what can happen if that decal gets in the right place and you sufficiently drive the movement, you can actually end up bending the little needle out of the out of alignment there, and so you'll need to come back in and make the needle straight again, or replace the entire meter movement. Anyway, what you can see here, there's a little bit of disagreement, but that's none of this stuff. This has been moderately tweaked in, but I haven't used it in quite some time, so it probably has to warm up a little bit. I have no idea of how accurate it is supposed to be. Anyway, what we're seeing here is the appropriate voltage that's showing 0.5 volt and roughly 0.5 volt there. Now, on this unit here, we have a dBm 50 ohm. So if I take this item back here, swap in my 50 ohm terminator and drop that back on, and then push this on the 50 ohm load, now we're starting to see the things line up again, because basically all we're reading here is just an AC voltage. And so we have to ensure that the correct impedance is being driven for what we're driving out here. So now on this guy here, I can actually set a dBm into 50 ohm. So let's go and select 0 dBm there. And doing this from in front of the camera is a little tricky. And then we're actually running into that part of the meter as well. There we go. So what we're actually seeing here is into this meter at the, at the right load, the right voltage. We're reading about 0 dBm. So I can step this down to say minus 10, and you'll see we drop down 10, and I can step down here and we come back up 10. And so I can follow that through in all of the patterns as we go down range, and we keep going down range all the way through. So this is showing the meter is basically working. It just needs to be tweaked a little bit and so on. Now, one of the things that I wanted to look at was that DC voltage. So let's grab our trusty EV blog meter. So now that DC voltage should come out and should be proportional to the full meter deviation. So if we come all the way over to 1, we're getting close to 1 volt there. And if we come all the way down to 0, we're reading 0 volts, and then a bit over 1. So the full, that DC output, even though it had that burnt item on it, was still showing a reasonable value. So I guess that maybe that's just gotten hot over time and has charred up a little bit. All right, let's see if we can take a look at this as an AC amplifier. Okay, so we're set up now with the unit connected, and you're going to sort of have to trust me on this one, because I don't actually have a I don't have an easily accessible way to show you this measuring, because the meter I'm actually using is sitting on my bench, up on my bench, which is above the camera. Anyway, what we have set up here is basically I have the 50 ohm coming in. I have it set to 0 dBm up here. And if we look and control it, remember we're looking off the back here. If I step that down half, we're dropping down 10 dB. So when I have it set up here, what I'm reading on my other meter is minus 2 dBm into 50 ohms, which is what I'm back. And sure enough, when I drop that down, it drops 10 dBm. So basically what I'm doing is I'm taking out a signal at minus 40 here, and I'm getting about 30 dB of increase, which is what should come out of there, and I should get 40 dB. Yeah, I'm actually probably exceeding the ability, but I should be able to get 40 dB of attenuation. We're driving out over the top there. But if I come down to 50 here and then step up, you know, yeah, it's not actually reading that because we're now at -1. Anyway, now at -50 and we're not really getting anything there. There we go. Oh, it might just be sticky connection on the thing. So at this lowest range here, I should get about 40 dB of amplification, and that's what I'm seeing. You know, I'm outputting -50 here, and I'm getting, you know, -14 on my other meter. So what I can do here is I can take this out, use it as that wideband amplifier, and you know, if I step up the frequency, you know, it maintains that amplification. Now I can't go too high because I'm reading that on a bench meter that doesn't go any higher than I think about a couple of megahertz. But as you can see, as I'm going through, I'm getting that consistent you know, reading there. Now we're going a little higher, which is probably due to this. We're at 500 kilohertz. And I think if I go to 5 megahertz, we'll drop off on my meter because I think my meter only goes up to like a megahertz or something like that. Anyway, what it enables you to do is to take a very low signal, put it in here, amplify it, and then use it later on in your test rig or so on. Anyway, that's a quick overview of and a look at the 400EL. The 400E will be virtually identical except with that flipped over and different inputs. These are great meters, and they can be picked up pretty much very inexpensively for you know, for on auction sites and so on. Well worth including inside your kit, and the form factor is just classic. Anyway, I hope you found that interesting. If you did, give me a thumbs up, and I'll catch you again later.